2, talk about defining limits and using limit notation. When you deal with limits, the idea is you want to know where the graph is going. The graph is this curve right here, which is your function, which is your y. So I want to know where is my y going, and that's when we use the word limits. So for example, so this is the definition given in the AP College Board video. Given a function f, the limit of f of x at x approach c is a real number r if f of x can be made arbitrarily close to r by taking x sufficiently close to c but not equal to c. Now when you read that and you're like, I have no idea what that means. So let me translate that for you, okay? If I want to find the limit of f of x as x approach a number, we're going to call that c. So here's c. That c is your x value. So in this case, I want to know that when x getting close to c, when x go to the c, where's your y going? Where's your function going? So if I were to follow this curve, I can see that I'm getting closer. I'm getting closer to c because c is right here. You guys see that? So I'm getting closer to c, and as I get closer to c, my y value go up to this number. In this case is L, right? So L can be any number we want. Is that good? We just use a letter to represent that number. Now, if I were to look at the right side, right? Because if I were to approach c from the right, then my function is going down. And again, it's going down to this y value. You guys see that? So what I'm asking you is, hey, as x get close to this number, where's your y get close to? Is it getting close to L or something else? So that's what we're talking about. So this is the notation for it. We're going to have to highlight that. This is how you write them. And I think we spent like maybe half a year writing this in pre-cal. So we want to know the limit as x approach c. What would that be in terms of f of x? So this is your x going to c. Where's your y going? Well, y go to a number, and that number is r. So we have to fix this. Let's change this to r. And let's change this to r. Okay? Because they want it to go to r, not L. The way we write it, so this is the notation. So let's write, make sure you know that. If I ask you to write the notation, this is what I want. I want this. The way you say it verbally is this. The limit of f of x as x approach c is r. So the limit of f of x, that's my y. When x go to c, y go to r, which is this one right here. We're going to use an example so you can see what it means. Example 1, I want to rewrite the limit from symbolic to verbal. So verbal is this one right here. Okay, so this is verbal. All right, that's the verbal one. So here it says, the function g of x, and that's your y, is modeling behavior around the value of x equal to 3. So there's your x. It is found that the limit as x approach 3, g of x equal to 17. What this tells you is, when x is 3, so let's say this is 3, your function, as it gets close to 3, will go up to 17. So this number is going to be 17. Is that good? Yeah? So again, if this is 3, either way, either from the left of 3 or from the right of 3, my function, my y value, this is your y value go to 17. Is that good? It's going to get close to 17. Okay? So if I want to write this limit in a sentence, we're going to write like this. The limit of g of x, which is the name of my y, as x approach 3 is 17. That's how you write it. Okay, so it's going to mimic this one. The R is the 17, the C is your 3. So one more time. As x get close to 3, y go to 17. That's what that means. Any question? So again, where's your graph going? Okay, when x is getting close to this number, where's your y going? Okay, where's the graph going? Now here, it says rewrite the limit from verbal to symbolic. Symbolic mean I want this one right here. That's the notation. Go ahead and read that and see if you can write it. Now, when you look at this, limit has 2 parts. So make sure you know the 2 parts. The first part is the x. You want to know where's the x going. The x is your independent variable. Is that good? Now, in this case, they try to trick you because they don't have x or f of x anymore. Do you guys see that? So the way you look at it is that if you look at this notation, that's h of t. So the t is your independent variable, because it's the one inside that parentheses. It's very similar to like f of x. Do you guys see that? So that t is your independent variable. So that is going to go here. Okay? That's your x right there. That's equivalent to the x. Now this tells you t is getting close to 5. That means t approach 5. The second part is up here. So this is your independent. The part up here is your dependent, which is your y. Well, your y, the notation is h of t. So that means h of t here. And where's h of t go to? Well, h of t is going to get close to 7. That means h of t equal to 7. So there's your x and there's your y. Okay? As x get close to 5 or as t gets close to 5, your y get close to 7. Any questions on that? Okay, go ahead and take a look at example 3. Now that you have we stray away from the verbal, now we're going to have a graph. What do you think your limit is? Go ahead and find that out. So it says, this is the graph. The name of the graph is s of x, right? So this is the graph of s of x. What do you suspect is the value of the limit as x approach 3 of s of x? So you take a look at 3. So this is your x value, which is your independent variable. So here's 3. As x go to 3, where's your function going? Where does your function approach to? 1 and 1/2. So if you take a look at this point, right, you can see that as I get closer to 3, yeah, my y value go down to this point. And it doesn't matter if I go from the left direction or from the right direction, my y value go to 1 1/2 or 1.5. So my answer is C. Questions on that? We good? Let's move on. Go to the next page. So the notes is going to cover verbal, graphical, and analytical, which is, well, and data. okay? Numerical. So let's take a look at example 4. Go ahead and read that and see if you can find me that limit. From the table of value of Q of t, so Q of t is that y value that you have. Which of the following is the most likely value of the limit as t approaches 2 of Q of t? So now, this is your independent variable. It's very similar to your x. So if you take a look at your t, you want your t to go to 2. You don't see 2 there. Do you guys see that? But you can see that had there's a 2, it should be right around here. So I can see that the table is approaching 2 from both sides around here. Are we all right? Yeah? 2 would be right there if we have a number there, right? But we don't. We don't know what, at 2, we don't know what the y value is. But we know the numbers closest to 2. So this is my t getting close to 2. So I want to know, for my y, what is it getting close to? So I can see that is moving up from negative 3.4 all the way to, at 1.99, is negative 3.499. From the right of the 2, is getting up to negative 3.5001. So we can assume that, hey, this thing is getting very close to about negative 3.5. So that's what that is. And that's it. Any question? Okay. Now, Ms. Shen, what if this thing is like a negative 4? Now we have a problem because negative 3.499 and negative 4, they're not closest to each other. Do you guys see that? So we can only determine if the number are somewhat like equivalent to each other or approximately the same. Yeah? If they're not the same, then we cannot say the limit is going to go to the negative 3.499, or let's say if this is negative 4, it's going to go to negative 4 because the number differs too much. Yeah? So in this case, the number doesn't differ that much. So we can say, yeah, it's going to approach that negative 3.5. Are we okay? Question. All right, example 5 is the last one. Go ahead and read that and see if you can make sense of this one. See which one is the answer. All right, what do you have? G? So let's check. It's just found that x approaches pi. So I want to show that x have to go to pi, right? The corresponding value of the function L, which is your y, will approach e. So x have to approach pi. Here, x approach e, right? This is y. Right? Y approach pi. That's not right. Y approach e, yes, but there's no limit notation for this one. So this is wrong. This has a limit notation, but x go to e. I want x go to pi. So that's out, that's out, that's out. These two. Yes? X approach pi, X approach pi. L of X have to approach E. L of X is equals to E or approaching E. That's correct. That's not correct. So yes, the answer is G. Any questions on that? All right, we're going to stop there. What we're going to do now is we're going to go straight into our homework, okay?